The next topic is Kirchoff's laws. Till now, whatever we have studied, which are using either resistance in parallel connection or series connection, and solving problems with how to reduce the series connection or parallel connection or group of series parallel, it's possible to find a voltage or current by this way. But if the circuit is a complex circuit, there are more power supplies, that means more voltage or more current sources are available in a circuit in between. So we cannot always use for the reduction of resistance like series or parallel connection. Every time we cannot consider that. So suppose a complex circuit which is having more than one EMF or resistance are connected in a complex manner, simplification cannot be done that easily like a series or a parallel circuit. Directly we cannot apply every time the Ohm's law. So in that case, we have to go for Kirchoff's laws. There are two Kirchoff's laws are there. One is Kirchoff's current law or KCL. Another one is Kirchoff's voltage law or KVL. Now, what's Kirchoff's current law? KCL. It states that the algebraic sum of current meeting at a junction in an electrical circuit is equal to 0. So, suppose we have a junction. See, for example, this is our circuit. This circuit is having junction and it consists of 1, 2, 3, 4, 5 branches are meeting at this position. So, Kirchoff's current law is also known as junction rule. So, junction means it is a point where two or more branches of a circuit element or two or more circuit elements meet, or there are two or more than branches are there. So, even you can term it as a node also. So, now as per KCL or Kirchoff's current law, algebraic sum of all the currents meeting at the junction is equal to 0. So, if you are looking here, there are 5 currents meeting, I1, I2, I3, I4 and I5. So, adding all these currents should be equal to 0. Now, whether current is plus or minus sign, it is depending on the direction of current. So, one direction we are assuming as plus, the other direction current should assume as minus. So, look here, for example, I am going to assume here all the current leaving, that means going outward, all the current leaving from the junction are termed as positive, all the current entering to the junction are termed as negative. So, look here, I1. I1 is entering current, so I will write it as minus I1. I2, it is going out. You check the arrow mark, it is going out, so it is plus I2. Now I3, look arrow mark, it is going outward, so it plus I3. I4, again it is going outward, so plus I4. I5, it is entering inside to the node, so it is minus I5. Should be equal to 0. Even you can take the opposite direction, it's up to you. But assume that one direction take as positive, another direction take as negative. So, I can write here as I2 plus I3 plus I4 should be equal to, take the right side, I1 plus I5. That means all the current entering to the junction, sum of all the current entering to the junction should be equal to sum of all the current leaving from the junction. So, this is called the Kirchoff's current law. So, algebraic sum of the currents meeting at a junction is equal to 0, or the sum of all the current entering to the junction should be equal to the sum of all the currents leaving from the junction. So, that's about Kirchoff's current law. Now, we will move to the next one, Kirchoff's voltage law or KVL. Kirchoff's voltage law. It states that in any closed electrical circuit, the algebraic sum of all the electromotive force, all the battery voltages and voltage drop across resistor or different elements should be equal to 0. So when you are taking a closed loop, one closed loop, algebraic sum of all the battery potentials EMF that or EMF and the voltage drop across the elements like resistor or a capacitor, whatever voltage drop across the elements, when you are adding all these things in a closed loop should be equal to 0. It is also called a mesh rule. You know, mesh means one closed loop or loop rule. So any closed loop, algebraic sum of EMF plus algebraic sum of voltage drop should be equal to 0. This is called a Kirchoff's voltage law. So when you are taking the sign convention for a Kirchoff's law, for example, I am just drawing for your understanding one small circuit over here. Now a small resistor, another resistor, say another resistor, 3 resistor I have drawn. Now see, this is R1, this is a R2, this is a R3, this is a V1. Listen here. Now when you are looking here, this is called a closed loop. See, it is only one current will flow here. Only one current, there is no junction so that so many elements are met, nothing like, only one closed loop or a closed say mesh or a loop it is. So only one current, say I am saying say I is flowing. That means the current flowing in this branch is I, in this branch is also I, in this branch is also I, in this one also I. So this is the direction. So all currents are I. Sorry, it is not I1, I just missed out. This is all I. So as per here Kirchoff's law, the voltage drop across the resistors and the EMF, adding all these things should be equal to 0. The voltage drop across the resistors and the EMF, adding all those things should be equal to 0. Now when you are applying it, so here also I wrote I1, so let it be I1. So now when you are assigning, how to assign the direct sign for a battery, there is no problem. You already know that this is minus, this is plus. Now the problem comes with the resistor. So how to assign the direction, how to assign the minus and plus symbols for a resistor based on what? So now for a EMF, I already told there is no issue in that, minus plus same. For a resistor, what we are doing is, current is in which direction? Look here, through the resistor I1 is entering here, I1 is leaving from here. So current entering is plus, current leaving is minus. So current entering is plus, current leaving is minus. When you are passing current like that, there is a voltage drop across this resistor. So V1 was here, after passing through this resistor, voltage is reduced here. So there is a fall in potential. So the fall in potential terming as plus to minus. Fall in potential plus to minus. So that is the reason I am just writing here positive and here negative. Similarly, when you are taking I1 entering to this resistor, so this point should be positive, this is negative. Here the voltage is higher than the voltage over here because there is a voltage drop across R2. So when current passing through R2, there is a fall in potential across R2. Now comes here, the current entering is positive, current leaving is negative. There is a fall in potential. So normally I am marking the current direction like this. So through the resistor, when I am considering, current entering part should be taken as positive, current leaving part should be taken as negative. So if I am writing the KVL for this one, minus to plus, so that is plus. I will take minus to plus as plus. plus to minus, it is minus. What is a drop across this resistor? I1 multiplied by R1. I1 multiplied by R1. Now see, plus to minus, minus I1 multiplied by R2. Plus to minus, minus I1 multiplied by R3 should be equal to 0. So algebraic sum of all the voltage drops should be equal to 0. So if you know V1 and R1, R2, R3, you can easily find I1. So that is Kirchoff's voltage law. So only you should take care of putting the sign. Only follow one sign convention always. See, some textbook you can see plus to minus they may be writing positive, minus to plus they may be writing negative. So that they are following that convention everywhere. But now if we are following this convention, follow the same convention every time so that your final answer will come as correct. So whatever be the convention you are following, you should follow the same. So now that only whatever I told you now, that is only explained here. A rise in potential is considered as positive, fall in potential is considered as negative. So based on that we are putting the sign. So when you are going through a resistor, current entering is positive, leaving is negative. When it is passing through the resistor, a voltage drop across it. So this is higher potential, this is lower potential. So this is plus, this is minus. So that is a sign convention. Now next one, what we have to talk about, mesh analysis. We will do a problems on circuit analysis techniques called mesh analysis. The basis of mesh analysis is Kirchoff's voltage law.